This is our first example. There's a block that is moving on a path, and after some point on, which is, let me just get my pencil here, pencil tool, and then which starts around here, it starts to take a curved path. And as it is, passing over uh, B, it has a speed of 3.5 meters per second. Okay, so this is some constant speed at that instant. And we are asked to calculate the magnitude of NB. NB is the normal force acting on the block applied by the path. And the next question is about the maximum speed v which the block can have at point A without losing the contact with the path. Losing the contact means now the path cannot apply anymore this normal force. Normal force drops to zero. Okay. So let's see how that will happen. First off, let's start with B. Now, as it is on B, this block of ours is on B. Here we have a drawing here. The type of forces acting on the block are the gravitational force in the downward direction, and our assumption is the gravitational acceleration is basically in the downward direction. Again, is in the downward direction. We have the gravitational acceleration. As a result of that, we have mg amount of force pushing on it, and then there is this normal force applied by the path on the block. Now, on this is one direction. Obviously, this block is doing a curvilinear motion, so you might ask yourself about the other direction. But the other direction motion doesn't really help us to configure this NB, because, like I said, as you resolve the vector equation of Newton's equation into two scalar equations, they become independent from each other. So here we have the forces acting on this block as mg and then the normal force. Now the question is there an acceleration there? Now when you take a look at the information about the speed, it's just 3.5 meters per second, so it's not talking about any acceleration. But how about the acceleration in this direction, in the vertical direction? So it's moving at that instant in a horizontal way, right? This is the direction of its motion. How do we know that? You can draw a tangent to that curve at B, and then the tangent would be horizontal, because from this center of curvature, which is shown around here, to B, we have a vertical line, and the tangent to that would be, in that sense, a horizontal line. So its motion is in the horizontal line. Now, here you need to remember the NT coordinates. Acceleration has two parts. One part is about the change of the magnitude of the velocity, and that part of the acceleration will be in this direction. So A tangential, we call it, right? AT will be in that way, which will not affect these equations, by the way, the equation in the vertical direction. And then the other type of acceleration, or the other component of the acceleration, is about the change of direction of the velocity. And as it is having, this block is having a curved path, the direction of the velocity will change. That means it's going to have an acceleration in the normal direction. And remember that the normal direction acceleration is always towards the center of curvature, and in this case we have a fixed center of curvature right around here, and as a result of that we're going to have an acceleration an, the normal component of the acceleration, in the downward direction. I can also draw it right over here, as we have this acceleration in the downward direction. This is And AN can be calculated in a number of ways. As we have the information about the velocity and the radius of curvature, this is the version that we use, v squared over rho, or you could use rho beta dot squared. Beta dot would be the angular velocity at that instant. As the velocity is already available to us and then the radius of curvature is available to us, we can easily use this version. Now, if we're going to use the nt coordinates, then an is positive in the downward direction, so that's why mg becomes a positive. So this is our summation of forces in the normal direction. Summation of forces in the normal direction will be equal to mg positive, and the normal force is in the negative direction with respect to this normal direction, and the resultant acceleration is positive, right? V squared over rho, it's always towards the center of curvature, and if you do the necessary math, you'll be able to calculate mb. Now, here again, you can say that what would be the velocity so that the contact will be lost, at after which velocity will this block lose its contact with respect to the path. And in that case, what you need to do, this is an extra question by the way, okay, what you need to do is make this NB go to 0. In that way, there is no contact between the path and the block, and in that case the only unknown becomes v, and as a result of this equation you'll be able to solve for v. This is exactly the same type of strategy we're going to follow in the next part of the question, which is asking us the maximum speed at point A. The only difference in point A is that we will need to calculate a certain component of mg, because mg, the gravitational force, is in the downward direction, and at point A, in the normal direction, we'll only be able to use a component of it, and this is its component. Okay, so this is 30 degrees, this is 30 degrees. The component we're going to use is mg times cosine theta at point A. So if you go to the next part of the question, here's our mg, and the component we're going to use of mg is in the downward direction this way. We know the angle, so this is mg cosine 30. Actually, in this equation, we should have this NA as a negative direction, because still we are writing this equation in the n direction, right? This is the en direction. En unit vector direction. So with respect to this direction, this NA is a minus sign, minus NA, but we are taking a look at the case where the contact is lost, so we take this NA to be equal to 0. That's why it doesn't appear in this equation, because we already declared that it is equal to 0, and the only unknown is the velocity at that instant. And if the block is moving at this velocity, then this is the point it's going to lose its contact. We're going to continue on with the next question in the next video.